Hello, thank you so much for tuning into my YouTube channel. Today's video is going to be a tutorial on Anaconda Python for machine learning, and it's going to be a beginner's guide. Let's get started. As I said, this video is going to be a beginner's guide on Anaconda Python for machine learning. Anaconda Python is the ultimate tool for machine learning beginners. The reasons for that are easy installation, package management, pre-built Spider IDE, support for major machine learning and AI frameworks. A single download gets you Python and hundreds of popular libraries, which is for easy installation. The package management includes Conda, a powerful tool for managing libraries and dependencies. The pre-built Spider IDE is ideal for coding and debugging in a user-friendly environment. And the support for major ML and AI frameworks include TensorFlow, PyTorch, scikit-learn, and so on. So let's first download and then install Anaconda. So to download Anaconda, you go to their website at anaconda.com and then make an account. Just like this. I'm just going to go with this email. Then you just choose this one. And then you just provide your email. And then they're gonna send you a link to download. Or you could just download it here, as you can see here. You just download it. I'm not gonna install it because I already have it installed on my machine. You have to also be careful to choose the one you want, Windows, Mac, and Linux. But I have Windows, so I just choose Windows. And it already downloaded for me here. So the installation is not that hard. You just follow the instructions and ensure that you add Anaconda to the system path. And I've already installed Anaconda and I'm not going to bother with that. But to verify your installation, you open up the Anaconda prompt and then write Conda version. So that's the way to verify that you've installed Anaconda. So the Anaconda is downloaded and installed and ready to go. Next, let's just explore Anaconda Navigator. Okay, here it is. This is the navigator. As you can see, it's very convenient. You have access to everything here. Spider is the one that I'm gonna be working on, and that's where you could choose your environment. But let's go ahead and create a new environment for machine learning. So we open up Anaconda prompt again, and we say Conda create name. We say machine learning environment. And I'm gonna make it be Python 3.9, and we just hit the enter. We answer yes, and all ready. And now we have to activate the environment. All we have to do is just say Conda activate machine learning environment, and it's all ready. We are in that environment. Now let's install the essential libraries. So we're gonna install NumPy, Pandas, scikit-learn, Matplotlib, and also Seaborn. We hit the enter. We say yes. It's still installing everything. Okay, everything is done. Okay, now we're gonna get started with Anaconda for machine learning. For that, we're gonna load and manipulate a dataset using Pandas. We're going to use the iris dataset, which is one of the most well-known datasets in machine learning and statistics. It contains 150 observations of 3 species of iris flowers, which are setosa, versicolor, and virginica. Each observation includes 4 features: sepal length in centimeter, sepal width in centimeter, petal length in centimeter, and petal width in centimeter. This dataset is commonly used for classification problems, exploratory data analysis, and testing ML algorithms. Let's load it and inspect the first few rows. This is our environment. Because I want to use Spider, I'm going to also install Spider. Because we are already in the ML environment, we don't need to activate it again. But if we weren't, you need to activate the environment before installing the Spider. Conda install Spider. We answer yes to this. Okay, the Spider is ready. Let's open it up. As you can see, the installation is complete and we are opening up the Spider. Okay, let's load and inspect the dataset. Here's the code for that. Let's run this one. So as you can see, this is the dataset, the sepal length, the sepal width, petal length, and petal width. And these are the species. If we open up this one, as you can see, the variable, sepal length, sepal width, petal length, and petal width, Setosa, versicolor, and then virginica. And these are all in centimeter. Okay, now let's go for data visualization using Matplotlib and Seaborn. Okay, let's do it first with Matplotlib. As you can see, this is the visualization of our data. And as you can see in this visualization, each species is shown using a different color. Okay, let's use Seaborn now. As you can see, both of them look the same, Matplotlib and Seaborn. They both look very much the same. Okay, let's now build a simple machine learning model. We're gonna create a linear regression model using scikit-learn to predict petal lengths based on other features. Let's open up another section. And here's the linear regression that we're gonna do using this formula. So we're gonna predict the petal length using other features: sepal length, sepal width, and petal width. So we're gonna split the data into X-train, X-test, Y-train, and Y-test. The X-train and Y-train are gonna be used to train the model, and then the Y-test is gonna be predicted. So X is all of the features, and Y is just the petal length. Let's also show the results side by side. So as you can see, these are the true value and these are the predicted. And the mean squared error is 0.13. The model has not done a bad job, as you can see here. Next is introduction to classification and clustering. A classifier is a type of machine learning model that categorizes input data into predefined classes. In this case, we will use a decision tree classifier to classify iris flowers based on their features. So here's the code for that. We're gonna use scikit-learn. We're gonna first prepare the data set. Then we're gonna split them into training and testing. And this is the decision tree classifier, which would classify the data based on their features. And then we're gonna predict some of the flowers. Then we're gonna measure the accuracy. And then here we're gonna also show the Y predict and Y test side by side. Let's run this and see what happens. So as you can see, the accuracy is 100%, and all the flower species have been predicted correctly, as you can see here as well. And we just used a very simple classifier called decision tree classifier. We use 80% of data for training and the rest for testing, as you can see here. Next is introduction to deep learning with TensorFlow. Deep learning is a subset of machine learning that uses neural networks to model complex patterns. Here we build a simple neural network classifier to categorize the iris species based on input features. The neural network consists of input layer, hidden layers, and output layers. The input layers takes in 4 numerical features. The hidden layers use ReLU activation to model nonlinear relationships. And output layers uses softmax activation to classify into 3 categories. Okay, here's the model. It's a very simple model. This is the input layer, this is the hidden layer, and this is the output layer. So it's not a deep neural network, it's a superficial neural network because it has less than 4 layers. So we have to first convert the labels to the categorical using these commands here. And then this is the network. We compile it and then we fit it. And then here we're going to evaluate the model on test data set. This is where we're reporting the accuracy. And then we're going to predict the test data. And then we're going to be displaying the Y test and Y predicted side by side, just to visually check the results. So let's run it and see what happens. So I actually noticed that I don't have TensorFlow installed, so we have to first install that. I wanted to first just use conda install TensorFlow, but apparently it hasn't been able to install it. So we have to find a way to install TensorFlow first. And again, because we're already in the ML environment, we don't have to activate it again. So I'm just going to do it one more time, conda install TensorFlow. We should say yes here. I think I had a mistype in the first one. That's why I just use it one more time. Conda install TensorFlow. I think I had some sort of a mistype somewhere that I didn't notice. Yes, this is the first one, and I wrote TensorFlow, but it should be TensorFlow, which was my mistake. So that's why it's being installed now correctly. I think it's all done. Let's go back to Spider and import TensorFlow. If no error comes up, that means TensorFlow has been installed correctly. No error came up, which means TensorFlow has been installed correctly. Okay, I already explained this one. I don't think I explained compiling and fitting that much. So this is where we compile the network using this loss, categorical cross entropy, and optimizer atom. And then we fit it, we train the model. Using our training data set, we train the model, and then we test it using our test data set. Okay, the code is ready. As you can see, I just had to add some stuff because I was receiving an error. I had to load the data again and then split the data into training and testing. 20% testing, 80% training, as you can see here. And X is all the characteristics and Y is the species. So we're going to predict the iris species using these characteristics such as sepal length, sepal width, petal length, and petal width, as you can see here. It's a very simple neural network with only 3 layers, and I've already talked about it. Let's just run it. So as you can see, the test accuracy is 90%. It's 96% to be accurate. And these are the results, as you can see. Only one of them is wrong, I think, which is this one, species number 8 in the testing data. If you want to have a higher accuracy, just change the epochs number, make it higher, or change the number of layers. Usually the deeper the better. Or change the activation functions. We're using ReLU here, but even with this simple neural network we were able to get a 96% accuracy, which is not that bad at all. So we showed that Anaconda simplifies Python environment management, and Spider is an excellent IDE, and data manipulation with Pandas, visualization with Seaborn and Matplotlib is very simple, and also the utility of scikit-learn and TensorFlow libraries were shown here. And you could also have access to the code using the link in the description section of this video. And that's about it. Thank you so much for watching this video. I hope you liked it and also found it helpful. If you liked it, I would appreciate it if you could subscribe to my channel and also share the video with your friends. Thank you so much and have a nice day.